Continue Chapter 3, Section 3, Problem number 3. Let's read the problem before we can solve this. The top two dolls that a toy manufacturer makes are called Baby Wiggles and Sleepy Baby. So let's call Baby Wiggles X and Sleepy Baby can be Y. To make a case of Baby Wiggles, it takes 5 units of raw material and 1 unit of time to assemble. To make a case of Sleepy Baby, it takes 3 units of raw material and 2 units of time to assemble. On a given day, the manufacturer has at most 150 units of raw material and 44 units of time. If the manufacturer makes a profit of 120 on each case of Baby Wiggles and 100 on each case of Sleepy Baby, how many cases of each type of doll should the manufacturer make in order to maximize your profit? So first step is let's write our objective function. In our objective function, we want to maximize our profit. And the profit here is you have $120 for Baby Wiggles, and Baby Wiggles was X. So you have 120X and $100 for Sleepy Baby, so 100Y is our objective function. Now let's determine our constraints. Our constraints, you have at most 150 units of raw material. So at most is less than or equal to 150, and this is your raw material inequality. So your raw material inequality, you have 5X and you have 3Y. And the next one is your 100, it is the 44 of the units of time. So at most 44 units of time. So this is your time inequality. So you have 1 unit of time for Baby Wiggles, and Sleepy Baby, you have 2 units of time for Sleepy Baby. So you have 1X plus 2Y. So now once we have our inequalities, again, don't forget the X and the Y is greater than or equal to 0, we can make our table. So let's substitute 0 into the X. So the X is gone. We have 150 divided by 3, which is 50. And then when you substitute 0 into the Y, that's gone. You have 150 divided by 5 is 30. So here you have 0, 50, 30, 0 is that line. Plugging in your test point of 0. So 0 is less than or equal to 150, which is true. So we shade below. The second inequality, let's do the same, make a table. So when X is equal to 0, you have 44 divided by 2, which is 22. And then when Y is equal to 0, you have X is 44. So here you have Y is 22, X is 44. And substituting 0 into X and 0 into Y, you have 0 is less than 44, which is true. So we are shading below. So now our corner points are 1, 2, 3, 4 corner points. And we have our objective function. Let's write this here. P equals 120x plus 100y. So our first corner point is 0, 22. The second corner point is 30, 0. And then 0, 0. And then the point of intersection we can solve by the elimination method. So we have 5x plus 3y is equal to 150. 1x plus 2y is equal to 44. So I'm going to multiply that second equation by -5 so I can cancel out my x term. So let's multiply all terms by -5. I have -5x minus 10y is equal to -220. And let's combine that with the first equation. So my x's cancel. I have -10 plus 3, which is -7y. -220 plus 150 is -70. divided by negative 7. Y is equal to 10. So once I solve for y, I can plug it back into one of the equations and solve for x. So if I plugged it back into the second equation, I have 2 times 10, which is 20. 40 divided by 20 is 24. So x is equal to 24. And this is my fourth corner point, is 24, and y is 10. So substituting each of the corner points into my objective function, I have 120 times 0 plus 100 times 22, and that is equal to 2,200. And the second one, I have 120 times 30 plus 100 times 0. 100 times 30 is 3,600. And then when I have 0 and 0, again, that's going to be 0. And plugging in the last corner point, 120 times 24 plus 100 times 10, that is equal to 3,880. And that is your maximum profit. Therefore, the maximum profit of 3,880 will be made when the toy manufacturer produces 24 cases of Baby Wiggles and 10 cases of Sleepy Baby. And that concludes Chapter 3, Section 3.